Okay, so we'll start with Scott Stevenson, who will be talking about shipping and some other issues, and so that's a really nice connection with the previous discussion that we had. Then we'll go to Franz Reuter, who would be talking about fisheries and ecology, or that's his background. We'll then go to Robin Bronin, who has expertise in human rights, and then with Mary Beth Murray, who is more human dimensions overall. And so we'll basically keep the format, the list that's there, but we'll start with Scott first.
All right, thanks very much, Stephanie. And thank you to all of the conference organizers. It's a real pleasure to be here. I'm Scott Stevenson from University of Connecticut, and one of the things I'm interested in is Arctic shipping, and specifically how to translate what we know about future sea ice projections into futures of shipping for the Arctic. Let's see if I can. Okay, so we have here a visualization of the minimum from last year, overlaid with shipping data from the Arctic Marine Shipping Assessment from 2004. As you can see here, there's the expected transits through the Eastern Arctic, through the Northern Sea Route, and through the Canadian Arctic Archipelago. But interestingly, it's sort of an exploratory voyage to the North Pole there. With an icebreaker. And so one of the things I'm interested in is understanding to what degree will those sorts of voyages into the Central Arctic and perhaps across the Central Arctic become increasingly viable into the future. And so I use climate models to try to look at that question. And so some of this material will kind of overlap, I think, complementarily with discussions we had in the previous panel. This is a visualization of the Northern Sea Route with some data from the CCSM4 model showing if you look at accessible days across the Arctic for a ship that has polar class capability, so a polar class 3 vessel. This is work that was published a couple of years ago in Polar Geography. And then look at it regionally across the coastal seas of the Northern Sea Route. You can see the largest amount of variability in the Laptev, the Eastern Kara, Laptev, and East Siberian seas, kind of illustrating the degree of uncertainty that we see in this specific part of the Northern Sea Route, which is important when we talk about future marine use of the Arctic Ocean. We're talking about the Arctic Ocean as a potential transit space for future vessels. And actually current vessels as well. To what degree will these specific regional parts of the Arctic will represent challenges for shipping in the future in terms of limiting our understanding of the future operational length of the season. And then if we look here, if we look at some bathymetric data, we can see that because of these key straits of the Northern Sea Route, which have in some cases very, very shallow depths, we're basically limited to ships of certain sizes for the most accessible nearest to the coast routes, particularly vessels that basically any vessel that's going to carry more than 20,000 deadweight tons is going to have to sail north of the New Siberian Islands, which potentially, of course, puts it more at risk for hazards closer to the Central Arctic Ocean ice pack. So there's a bit of a trade-off there between cargo vessel size and potential future accessible season length. Okay, as we've seen already in a couple of the presentations, there's a lot of variability in terms of what the climate models tell us. You can see, I like to show this slide because it really shows us what kind of a mess the total length of the season might be if we look just specifically at the sea ice extent for September. This is work by Francois Massenet in 2012, and then the observational data there in the black, showing us the 29 CMIP5 climate models. So what I'm interested in is translating these projections into future operational sea ice navigation lengths. So what I've done in some work that was just published last year and hopefully will be published again in the near future is compare some models from this operational navigational perspective. This is comparing the CCSM4 model, which I found to be very conservative, compared with the access model. And you can see for 3 different vessel classes, open water vessels which don't have any ice strengthening, polar class 6 vessels, and then polar class 3 vessels. You can see there's an enormous amount of difference for identical time slices between these 2 different climate models. And so that really sort of underscores the extent to which model choice matters as far as making operational predictions for the future Arctic Ocean. Okay. So this is work that recently published in Earth's Future, where I'm looking at the question of trans-Arctic access, but with kind of a specific interest in looking at the potential future of the transpolar route, or the sort of least cost route going directly over the North Pole or near to it. What we can see here, this is an average of the least cost transit routes from 2 locations in the North Atlantic to the Bering Strait. As you can see, there's access at least at some point during the year for both the Northwest Passage in the west and the robustly accessible, for the most part, at least in summer, Northern Sea Route. But what we can see is that comparing this nearer term time slice from 2011 to 2035 with a mid-century projection, we can kind of see an overall gradual migration of the least cost routes from the Northern Sea Route towards the Central Arctic Ocean. So again, at the same time that we acknowledge that there's going to be obviously limited periods of access, specifically confined to summer, and that the ice is going to be coming back every winter. This is obviously very important to emphasize time and again. We will at the same time see some gradually increasing migration of these routes if we're only interested in the least cost transit access perspective. Okay, breaking it out by models, what I've done here is I've shown the 10 models that I was mostly interested in. The red routes show the transits which were more likely to happen on average, and then the blue routes show those routes which were less likely to happen on average for this particular time slice, RCP 4.5. As you can see, the Central Arctic tends to be more robustly accessible than the Northwest Passage in a lot of these routes. There were only a couple of models where the Northwest Passage was the clear winner, which was the MIROC 5 there and the MPI ESM MR model in the bottom right. So at least for the set of models that I looked at, these were the models that kind of stuck out as being outliers when compared with the others. Here's just a table that illustrates kind of some quantitative numbers to go along with the visualizations I just showed you. There were not any Northwest Passage routes at all projected in some of the models, and then 3 of the models there accounted for nearly 3/4 of all of the Northwest Passage routes. So there clearly are significant regional differences in the degree of future access. This will not come as a surprise to anyone who studies sea ice dynamics and sea ice modeling. But for policy, I think it matters enormously to point out these real operational constraints, and that's what I've tried to highlight with this work. And then kind of getting back, I think this is getting back to what we were just touching on at the end of the last session, where we were talking about to what extent does the choice of climate scenario matter. Anders pointed out very, very astutely that until mid-century, there's not a whole lot of difference between the lower emission scenarios and the higher emission scenarios, and I found that to be true in my work as well. As you can see here, when you use a polar class vessel, it matters enormously more for future accessibility than whether or not we're going to be than which climate scenario we're going to be using. So that basically access to infrastructure is the take-home point here, is what matters more than climate scenario, at least until mid-century. Okay, so conclusions, there's the viability of the transpolar route is found to increase substantially, gradually towards mid-century in a majority of our models. But in the near term, the Northern Sea route will remain the most accessible route. Environmental concerns will potentially shape the future use of the transpolar route. There's been some discussion, well, if the Arctic actually does represent potential carbon savings as a result of it being a shorter route than traditional routes through the Suez Canal, maybe that will potentially make it more attractive from an environmental perspective. But of course, we have to always keep in mind the real accident risk and climate feedbacks potentially as a result of black carbon deposition on ice and snow that could result from that. So for the moment, the economics of the route remain prohibitive. Perhaps we'll talk about more of this in future talks and future sessions. But potentially in the future, avoidance of icebreaker fees along the Northern Sea Route could become a possibility. So I think I'll stop there for now. Thanks very much.
Let's transition to Franz. While we're doing that, does anybody have a quick question for Scott? Brendan?
Yeah, can you say anything about the insurance industry and how that plays into the cost effectiveness of shipping routes?
Sure, that's a great question. My understanding of the insurance space right now is that it's still kind of a wild west, and they're trying to figure it out. And it remains one of the key economic uncertainties for future marine use of the Arctic Ocean, because there isn't this assurance that hazards will be covered by insurance. There are certain kind of niche operators which are entering this space, and they for the most part are those operators which have been using the Arctic Ocean for not transit but for destinational access purposes for some time. But it's an arena that's very much in flux right now, and I would expect that we probably won't see it fully flesh out for the next maybe at least 5 years.
Okay, I'll be switching gears a little bit here. We've heard a lot about sea ice variability, and potential impacts for shipping, and here I'll focus on other biological resources. Just sort of a big picture overview here. From a biological perspective, the two main issues associated with increased CO2 is really the warming aspect, and we've talked a lot about the ice and warming, and the other one that we haven't really talked about is ocean acidification. In terms of the warming, the main issue really is just the longer ice-free season that's associated with a longer growing season, changes in the phenology of when the biology happens, and the potential for new blooms and maybe increased productivity or at least changing productivity because of that. If we look at it sort of spatially, the production in the ocean really changes quite a bit as you go from south to north, from the bottom to the top here, with spring bloom and a late fall bloom typically in the more temperate areas or subarctic areas. Where you have sea ice, you often get a very peaked single bloom of production, and then in the more northern areas you get a lot of under ice production when the ice is thin, and then sort of a flat production throughout the year. And that's kind of idealized here, but that's borne out by the data for different regions here. This is satellite-based estimates of a chlorophyll standing stock. And so we can use this spatial gradient sort of in a space for time substitution to think of how things in the north may change over time. So we may expect to see in the more northern areas over time the occurrence of fall blooms, for example, and that's exactly what's been observed. This is just based on satellite data looking at the frequency of, in blue, just flat production, a single bloom, and a double bloom for 3 different time periods. And what stands out is just the decrease in the pixels that just have a flat bloom or flat production period, and the strong increase in areas that have a double bloom, and that's mostly on the Russian shelves here, where there's been a large increase in the occurrence of double blooms, so extra blooms in the fall. And that's associated with just an increasing number of windy days over open water. It's not that it's necessarily windier, although that is the case too, but that these storms occur over open water and can mix up the water and lead to additional production that you wouldn't get otherwise. So The big question, of course, is how does it affect sort of overall production? Can we expect an increase or decrease in overall production? And just sort of summarizing a vast body of work on that, it's highly uncertain, but in general terms, we think that on the shelf seas around the Arctic Ocean, production is probably going to go up with a lot of regional variability, with a lot of uncertainty about it. It's almost certainly going to go up along the slope, and that has to do with more ice-free days along the slope and the possibility of upwelling along the slope. And in the basin, there's various influences on production, and it's probably not going to change very much. The changes in ice, both the fact that we have a longer ice-free season and the fact that we just simply lose habitat, and I haven't really talked about that aspect yet, but there's of course a number of ice-associated species that depend to varying degrees on the ice that are going to be sort of the losers in this game, and that's polar bears, ice-associated seals, and then a whole under ice community that's basically probably going to disappear because the multi-year ice has a very different under ice community than the single-year winter ice. But associated with the changes in the phenology are changes in what we call benthic pelagic coupling. That's where the production goes. And that's been fairly well established in a lot of the subarctic regions, and is presumably also going to happen in the higher latitude regions. But essentially what we see is if we have a bloom that occurs in very cold water, for example an ice edge associated bloom, a lot of that production, basically it's too cold for the zooplankton to graze the production down, so a lot of that production is going to go to the bottom, and it'll feed benthic critters that then in turn serve as food for things that we often care about, like diving birds, eiders, walrus, gray whales, and others. Whereas if the bloom occurs not associated with the ice, but later in the season in thermally stratified water, a lot of that production is consumed in the water column by zooplankton, and it can then feed pelagic fishes like the gadids, cod, and salmon, and others, as well as birds and mammals that directly feed on plankton. So very different pathways, potential pathways, and we can expect a change in that. And there is some evidence in the Pacific Arctic for increases in zooplankton abundance, and associated with that some increases in warmer years of plankton feeding seabirds, and also, as just one example here, an increase in the body condition index for bowhead whales that presumably is related to better food availability. Shifting to just the direct effects of ocean warming, what's been looked at a lot and observed a lot is just shifts in distribution of different species, and that has kind of led to the term borealization of the Arctic, where we see northward shifts in a number of species as it warms up. This is just northward shifts over a warming period of about 25 years in the Bering Sea, where a lot of fish tended to shift to the north as it warmed up. Some shift south. There's a lot of variability, but on average a northward movement. Similarly in the Atlantic, Arctic, and the Barents Sea, there's been a decrease in a number of Arctic species and increases in boreal species in that area. Then finally, both the warming aspect and ocean acidification have a direct impact on the growth and physiology of a lot of species. Ocean acidification in particular affects crabs potentially quite dramatically. And then in terms of the temperature effects, there's some winners and some losers. The temperate species will do better. Arctic species won't do as well in a warming scenario. And I'll skip over that. That's just showing different temperature responses. There's going to be some winners, some losers. Ocean acidification is going to be particularly dramatic for crab. They're very sensitive to that, and there have been some simulation studies showing that at a pH of about 7.8, we can expect a decrease in this is actually a population dynamics harvesting model, and we can expect a decrease in the volume of catches of some of the large commercial species over time. For the fish species, it's more of a mixed bag. Some species are more sensitive, tend to have higher mortality in a high pH, in a low pH environment. Others are more resilient, and lab studies haven't really shown any effects on survival. And some of the simulations that we've done suggest that we can kind of buy time through adaptive management strategies to at least sort of give us more options for the future. In terms of fisheries, the Arctic fisheries make up a fairly substantial portion of the world's catches. About a third of that comes from the Barents Sea, Norwegian Sea, a third from Iceland, Greenland, a third from the Bering Sea. And the largest fisheries are at the edge of the Arctic on these Arctic inflow shelves. What's going to happen in the central Arctic, we don't really know, but most experts believe that a commercial fishery, at least in the western Arctic basin, is very unlikely in the foreseeable future. One thing I wanted to mention is just to remind me not to forget that there is the other ice, the glacier ice. This is just outside Juneau, taken a few years ago, and he's standing under about 40 feet of solid ice, and that a year later was gone. And the point is just that there's a lot of changes in the glacial landscape that changes the terrestrial marine linkages. It has a fairly strong impact on the coastal environment in terms of freshwater inputs and associated nutrients, in particular micronutrients like iron. And that has downstream effects. You know, this is in southeast Alaska, but that current flows all the way around Alaska and all the way through the Arctic, so it has downstream effects as well. So I just try to think about, you know, from mostly a fisheries or living marine resource perspective about some of the things that we can think about. Clearly there's sort of a need for a proactive management. This is really more from a sort of an adaptation standpoint, adaptation to maybe inevitable changes. But in terms of proactive management, in fisheries, we do a lot of what's called management strategy evaluations, where you basically try different harvest strategies and figure out how that kind of affects your future trajectories. We certainly are thinking about essentially kind of constraining fisheries until we know more, if we ever wanted to allow fisheries in the more northern areas or in the high Arctic. Really, in a lot of areas around the Arctic that have only recently become ice-free, we've only just begun to do some surveys, so there's certainly a need for some research surveys to establish a basis. At the Pan-Arctic level, I think we kind of need to obviously pursue a coordinated management across nations, because a lot of these stocks, whether it's fish, birds, mammals, are shared stocks and occur in shared waters. At the local or regional level, from a fisheries perspective, again, there's a lot of coastal communities that depend on subsistence resources, fishing, other things. Helping communities to retain fishing rights and remove barriers to entry so they can participate in existing or potentially new fisheries would do a lot to increase the resilience of those local communities. In general, we should think about supporting a more integrated assessment and ecosystem-based approaches in the high Arctic as well, because if we think about other stressors in that area, anything we can do to reduce or mitigate non-CC stressors will also help us increase resilience to climate change. And I think that's it.
Thank you.
So I'm going to be talking about the human rights implications of what all the previous speakers have talked about, because in the decades that I have worked as a human rights attorney and then recently got my PhD in 2012, the issue of community relocation and the fact that land is going to permanently disappear, the places where people live is no longer going to exist, and we have absolutely no governance structures to figure out at what point in time people should be relocated. And I'm talking about Lower Manhattan also, even though most of my work has been in Alaska. I'm not kidding. Lower Manhattan is going down. And we need to figure out how it is we're going to protect people as the land on which they live disappears. So what am I talking about when I'm talking about relocation? First of all, I'm talking about entire communities, not individuals, because that's the places where people live. It's got to be voluntary. So the forced relocation of people has been uniformly disastrous for all populations that have had that experience, including in Alaska during World War II, where 10% of the population was killed as a result of that relocation. It needs to be planned. And what I mean by that is this cannot be as a result of Hurricane Sandy coming in and displacing people, because then you're experiencing a humanitarian crisis and you need to get people housed and food as quickly as possible. This should be a multi-year, possibly a decade process where you are planning for people's future so that they can rebuild their lives and livelihoods. And most importantly, this is about people's lives and cultures being able to be maintained or rebuilt in a new location where they have not lived before. So the reasons for community relocation are going to be a multitude. It's going to be because of extreme weather events and also because of these slow ongoing environmental processes like sea level rise and erosion. And one of the reasons why we don't have any governance structure for this is because right now in the United States, the primary federal legislation to deal with this issue only talks about extreme weather events and primarily talks about repairing and rebuilding in the places where people live. So our current national legislation here in the United States is completely ill-equipped to address the fact that people need to be relocated to new places. And one of those indicators is going to be if property is repeatedly damaged and destroyed because of those extreme weather events, how many times is government going to want to rebuild that infrastructure before they determine it's no longer cost effective? So as I said, most of my work has been in Alaska. The federal government has been studying this for a very long time. And in 2003, when the U.S. Government Accountability Office looked at what was happening in Alaska, they found that 3 communities in Alaska were choosing to relocate. So it's really important in the context of what's happening in Alaska to understand that communities are choosing to relocate because they have determined that it is their best long-term adaptation strategy. They have done tremendous advocacy with the White House and Congress to get themselves relocated, and no community has yet been able to be relocated because of these governance challenges. And that's despite the fact that 6 years later, the U.S. Government Accountability Office found that the number of communities seeking to relocate had quadrupled to 12. So the 2 governance issues that we need to be dealing with are, one, at what point in time should communities think about relocation because of the environmental changes that are happening in their environment? And then 2, which government agency should be responsible once that decision is made to relocate? Which government agency should be responsible at a federal, state, and local level for orchestrating that relocation? And nobody has the answer yet to either of these questions. So I'm thinking about solutions. I've been thinking about solutions since I started doing my research 10 years ago, and I came up with this adaptive relocation framework, which now the White House is trying to think about how to implement, as well as the Department of the Interior, where you always start with protection in place. People need to be given the resources, so protection in place is always the first place where you start. But there will be a time when relocation will be inevitable, and it's critical for local communities to be figuring out what those relocation indicators are. Saline intrusion, repeated damage to infrastructure, other implications for public health, and then you start a relocation process where you're able to rebuild that infrastructure and help people rebuild their livelihoods. We have been really fortunate. We received NOAA funding a year ago, and we just received NSF funding to work with 14 tribes in Alaska to actually start implementing this. And one of the critical pieces in looking at the way relocations need to occur and our own denial, right, our own denial about what is happening is we need to be able to understand the risks for our environment and then be able to model it up. So we are now working with 14 tribes, and I'm going to give you 2 examples of how this is working. So there was just an incident off the coast of Shishmaref that happened, which is in northwest Alaska, about a month ago, where 2 boats that were out walrus hunting got stranded on the ice and needed to be rescued. And so we are now working with NOAA to figure out what was going on with those ice conditions and use those local observations of the hunters from Shishmaref to see where the synergy is and to create an ongoing process where people's expertise at the local level can be then modeled up to a regional scale so that on both levels you have better idea of what's going on with sea ice. And then the other example that I have is this is about people's health and well-being and developing community-based health monitoring. So I just gave a keynote lecture to 1,000 epidemiologists here in the United States. They were in Alaska, saying we want to create this community-based health monitoring, which means that, again, people at the local level are monitoring their health and then figuring out what the interventions are, because we know that climate change is going to impact our health. And I asked them to come up to me to let me know if there were any models, because we've been researching it and hadn't been able to find any models of community-based health monitoring, and none exist. Not one of those 1,000 epidemiologists came up to me afterwards, except to say, when you develop it, we want your toolkit because this is really important. And so the application in Alaska, we are having an outbreak now of bees in our state, and during one of our teleconferences with the tribes, it turned out that they're all the way in northwest Alaska now, and one of the people in their community got stung. Well, they've never had bees before, and so they would have no idea that there could be an allergic reaction to that bee sting. So we are going to be hosting a community-based adaptation workshop, our first, in September, to try to bring these multi-levels of governance together so that people's human rights can be protected at the local level, and also for the folks who are doing modeling at higher levels, that they can get access to that critical expert knowledge to make those models more robust. Thank you.
So while we're bringing up Mary Beth and setting up her slides, does anybody have a question for Robin? Yeah.
Thanks for the presentation. That was great. I wondered, when the president went to visit Alaska and the Native communities in the Arctic last year, one of his statements or part of the commitment was to designate the Denali Commission as a point agency to help facilitate and coordinate the relocation. Has there been any movement on that?
They're working on it. So it's a work in progress. It hasn't yet been implemented.
So I'm going to give a big picture overview of demography and energy use and internet use and industry at the pan-Arctic scale, and then talk a little bit about some of the issues associated with development and change in the Arctic, and then a few examples from Canada, which I used to know Alaska better, but now I know Canada better. Okay, great. So this is the various definitions of the Arctic, and I'm going to speak about it most broadly, which is the AMAP definition, which is the red line. So it includes all the Arctic countries, a big chunk of the subarctic in Alaska, Canada, Quebec, and the Russian subarctic. So we have these different countries, and I think it's important to think about this particularly in terms of the science ministerial. These countries have very different agendas. I'd be happy to talk about the issues that I faced in Canada trying to convey scientific information to the Arctic Council. My institute is permanent observer status at Arctic Council, and it's very different than it is here in the United States. These are the maritime boundaries, so it's complex jurisdictional boundaries. In Canada, for example, the Northern Territories have no jurisdictional rights over the waters, but lots of jurisdictional rights over the lands because of the land claim settlement. Arctic, as everybody knows, is a complicated place. Many different indigenous peoples, many different languages. These are, let's just look at Canada, all of the different languages spoken in the Canadian Arctic, most of them still being spoken. This creates a lot of issues around communication, particularly when talking with older people and trying to convey information or build adaptation strategies and create new partnerships. So let's just take a look at the population distribution in the Arctic. Very different in the Scandinavian Arctic, where we have large numbers of people. I'm sorry you can't see the numbers, but very large numbers of people as compared to, say, Greenland and Canada. So for example, the territory of Nunavut has less than 30,000 people. The university that I work at has 34,000 students. So in terms of capacity and dealing with change and managing change and communication, this creates a whole host of issues. Canada's Northern Territories together only hold about 100,000 people. So compared to the Russian Arctic, compared to even the Alaska, it's a huge demographic differences. And you can see how the population is distributed here. So rural on this map on the right is orange, okay? So if you look at the Canadian Arctic compared to the Scandinavian Arctic, it's almost all rural. And rural is defined as less than about 5,000 people. Okay, so pale blue is 10,000 or less, greater than 10,000, and then the darkest is less than 50,000. So small populations, widely distributed. This is the distribution of indigenous populations in the Arctic. So dark brown is the dark brown dots are places where the indigenous population represents 50% or more of the population. The territory of Nunavut is about 97% indigenous. Again, very different than you see in Finnmark and in Scandinavia. And in Alaska, we're looking at between 10 and 25% of the population. And then population size and growth. So the annual change in percentage here, the areas that are in blue is where we see a percentage change of greater than 1% per annum, and then in red where it's less than 1%. So we see rapid population growth in the North American Arctic, much different pattern in the Eurasian and Russian Arctic. And Greenland is kind of holding steady. Okay, this is the distribution of men and women, and this is something to think about. This is important in terms of long-term adaptation. What we're seeing in many regions of the Arctic is a disproportionate number of women to men, with women tending to out-migrate from a lot of communities to more southern regions or to urban regions. So what we have here is the number of females per 100 males in the age groups of 15 to 64, and areas that are in blue are where we have 90 to 95 or less than 90 females for every 100 males. So we're seeing a gender differentiation across the Arctic as well. The other thing that I think is important to think about when thinking about adaptation and change is that populations, particularly in the North American Arctic, are very young. The average age in Nunavut territory, and I had to remind myself of what it was, is 24.7 years of age. The average age in the rest of Canada is 42. So we have a very young population, and we have a young population having a lot of youngsters. So the average, you know, in Nunavut territory, most women are having children before they're 20. In the rest of Canada, the age now is approaching 30. So we've got a young population, a growing population, and some different educational issues that I'll touch on quickly. So this is the share of the population around the Pan-Arctic with post-secondary education. The palest color is where less than 50% of the population has post-secondary education. And again, you can see huge differences between the Eurasian and Russian Arctic and the North American Arctic. Almost all of Canada's Arctic, with the exception of Nunavut, has less than 50% of the population with post-secondary education. On the right, this is post-secondary education by gender and the male-to-female ratio, and what we see is that in general, in the North American situation, we have more women getting post-secondary education than men, and the opposite situation in the Russian Far East and Scandinavia. Okay, so let's talk a little bit about infrastructure, because I'm thinking about shipping and some of the discussions we've had earlier today. Infrastructure is a real issue. Where is it? How is it distributed? I was interested to see the model projections on shipping routes and thinking about where's the infrastructure to support shipping through the territories. For example, in the case of the Northwest Passage, not really there. So let's look at cell phone or cellular coverage. This is GSM coverage. Yellow is where you have GSM coverage, and red is where you have 3 GSM. Well, this is my country. Bit of a problem. I run a research station in Yukon Territory. I have no cellular communications, no internet communication except by satellite. This is a real problem for people in the north. Russia is a bit of a blank. And then by contrast, if you're in Finnmark, you can be on a bus in the middle of nowhere and have wireless internet connection. So this is a problem for people in the North American Arctic and in the Canadian Arctic and in Greenland as well, as they try to develop their local economies, as they try to build out their educational infrastructure. There are very little in the way of plans in Canada to make communications, at least in Nunavut territory, better. The long-term plan for Northwest Territories is to have fiber optic communications to every single community, but that's possible in the NWT because almost all those communities are connected by a road system. In the archipelago and the other parts of the Arctic, this becomes an extremely expensive problem. Yet at the same time, you can see that greater than 85% of the population in Alaska wants to and accesses internet, and even in Canada, in Nunavut, where we have very poor communications, the percentage of the population that is accessing and trying to use the internet is between 50 and 70%. So where are these people going? To the one internet hub in their community, which is probably the school. And then I just wanted to quickly look a little bit at industry. So the proportion of employees in the north working in the primary sector, 20 to 40% is brown. So we see that really in most places in the north, the percentage of people working in the primary sector is quite low. It's less than 20% of the population. So what is everyone else doing? There is a fair bit in the service industry. I just want to go back to that. There's a fair bit in the service industry and in tourism and things like that, and then there's a lot of unemployment. Okay, these are the transportation routes, and we've already talked about that a fair bit, and then the zones of marine activity. And there is a lot of variation around the Arctic in terms of marine activities. How much employment is that bringing locally to people? Hard to say. It's very small, and it's often seasonal. So in Canada, where we have a marine transport system that delivers supplies to the communities, that's about the only way they can come in by plane. There's seasonal employment for people, but then after that, there's very little. So yeah, here's the economy by sector here, and you can see that most of it is other sectors, and green is the primary sector. And for Nunavut and northern Canada, the statistics are hard to say, but there's big disparities across the territories. Generation of electricity by source. So this is really interesting. I mean, Alaska, fossil fuels and hydropower. Yukon Territory, quite interesting, wind and other sources, and a lot of hydropower. Now there are fossil fuels being used in Yukon, but comparison to other places, Nunavut, that is the only option for generating electricity is through fossil fuels. There's a possibility for hydro, but none developed. And then energy use and production. You can see some territories, some parts of the Pan-Arctic produce a lot of energy, and others are completely dependent on outside sources. So I'm done with that. So I guess the take home from all that is that where I'm sitting and looking at this, I don't see any major changes in these patterns in the next decade or even the next 20 years. And
for us, at least in Canada, and thinking about the northern parts of the country, the functioning and the survival of those places is entirely dependent upon the south. And when people in the south look at the north and they see less than 100,000 people, what they see primarily is economic development flowing south and not staying north. And this is a huge problem, particularly I think in Canada and in Alaska, where people have settled their land claims and they have rights to the resources. And we're now seeing discussions, particularly in Nunavut, around Inuit rights to patent natural resources. So I'm involved in a project that's looking at bioremediation of oil spills in the Hudson Bay region, and there's a lot of genomics involved in that, and the Inuit partners on that are interested in acquiring the patents on the genome of the bacteria that would be possibly out there to bioremediate. So people are looking for ways to adapt, they're looking for ways to improve the quality of their lives, and the main issue, I think, is the huge range of variability, not just within a single country, but around the Pan-Arctic, and trying to cope with that variability in terms of culture, politics, economics, and environment, where we actually need to have some common solutions to the issues we face, because ultimately the problems are common problems. And now I'm done.
The Arctic means many different things, depending on where you are, right? So the variability, you know, in terms of shipping, you know, what is the shipping through the Arctic? Well, it depends on where you are. What is the variability in terms of the human dimensions, you know, with socioeconomic patterns? It also depends greatly on where you are. So with that, let's open it up for questions and comments. Peter wants to start again, so go ahead.
Just before I forget it, I had a question to Franz about productivity and northward shift. Isn't there at some point a limitation by light in terms of the productivity? If you go too far north, that you cannot get the primary productivity up enough so that fisheries could develop?
So I think the question was about the light availability. Yeah. Well, in the summertime, there's certainly plenty light. That's not typically a limitation. What's limiting is nutrients. So, in spite of I mean, as long as you have ice cover, obviously, there's a light limitation. As long as you have some mechanism of getting nutrients into the surface waters, you can enhance production. And in the high Arctic, there's it depends on the balance between stratification and mixing, and because of the increased fresh water in the Arctic, particularly in the western Arctic, the thought for a long time was that a stronger stratification will prevent that mixing of nutrients from the lower layers, and so that might reduce productivity in the high Arctic.
Very quickly, low light angle doesn't make any difference there?
Well, it makes. I mean, it's limiting in the parts of the season. It's not the limiting factor in the summertime for production, typically.
Okay, so we have Anders and then Vladimir.
As an ignorant physicist, I have to ask, there's no possibility that the ecosystems have a self-amplifying, collapses or something like this? That was a long time ago when the nonlinear dynamics chaos people dealt with ecosystems, but this is off the table, right? Ecosystems are relatively stable.
Well, we can't really say that. Most of the modeling work is based on the rules that we understand that currently operate. If those rules change, we don't really know what's going to happen, and these nonlinearities are typically not really captured in the model. So all kinds of things can happen, and we do have some examples. For example, I did tell a story about the changing pathways of where the energy goes, that more of it tends to stay in the pelagic realm when it warms up. So we were expecting that pelagic species, and that includes the largest single species fishery in the world, walleye pollock, would do better in that kind of environment. But as it turns out, because of changes in the food web structure, they actually don't do better, and that's because in a warming world, the species mix changes. You shift to smaller species, you get a longer food chain, you get a lack of large fatty zooplankton, and it turns out walleye pollock actually don't do very well at all in a very warm environment.
Vladimir and then Brendan.
Yeah, I have a question to Robin, I think, about relocation. So it seems like it's really getting worse and worse, and not only in Alaska and other places, in Russia, for example. But this relocation is very, very expensive. So it's really expensive. And I think one of the major question is actually where to relocate. Because the worst case scenario, you spend all these millions and millions of dollars, and then in 15, 20, 30 years, you'll have the same problem.
Thank you so much for asking that question. So the funding issue is actually a red herring, because part of the problem is that we do not have a relocation institutional framework, so we are not wisely using our funding. And in the project that we're currently doing, one of the communities has received $42 million between the years 1982 to 2009 to just study the relocation issue. And had any of that funding been used to actually facilitate the relocation, we would have significantly decreased the cost. The other piece is, if we have that adaptive governance framework, funding is always released when a disaster occurs, and we just need to be way more strategic about how we use that funding. Is it really appropriate to use that funding to repair and rebuild in the place where a disaster is going to occur again, or should we think about a relocation process? And then the issue about where should people go is one of the biggest issues that needs to be figured out all over the world. And that is something that national governments actually need to start thinking about, or else we will have a humanitarian crisis in Miami, for instance.
Brendan and then Moji.
Yeah, I just want to turn back to the ecosystem for a second and ask Franz, do you think it's fair to say that maybe the hardest thing to look forward to in sort of describing the marine ecosystem in the Arctic Ocean in the future will be the outcome of the community interactions, competitive interactions particularly?
Yeah, I guess that's probably fair to say. That's where the largest uncertainties are, and I had meant to kind of point that out at the beginning of my presentation. You know, we've heard a lot about the uncertainties in the physical environment, the changes in ice and temperature and so forth. You can basically multiply those uncertainties by probably a factor of 10 or more, and once you start talking about the biological world. For example, in fisheries, what we are pretty good at is actually dealing with uncertainty. Fisheries has for decades, if not a century, taken a statistical approach to trying to figure out how much fish you can catch, and so we typically try to incorporate the uncertainty and just make the best decision about future harvests based on the full range of based on the uncertainty as we understand it. But the community interactions piece, we don't really understand very well, and we don't really know how to adequately capture the uncertainty that's due to these interactions in our models.
Moji?
I'm not sure if this is the right panel to ask, but and on the other hand, I may be also misinformed by the German press, but we heard about relocation, and this actually, for those people who must be relocated, is quite a disaster. However, that's only one side of the coin. Aren't there people out there, especially in Greenland, who are looking forward to global warming, especially politicians, to get hold of the gas, the natural gas, of the oil, of the metals, buried under the ice sheet? Is this an issue at all, or?
Yeah, so this also came up yesterday, where I got a lot of questions about diverging interests and how some people are looking forward to a warmer Arctic and what the development opportunities might bring, and so maybe it'd be great if you could address that as well.
So on Monday, before I came here, I was at the Pacific Northwest Economic Regional, whatever it's called, I can't remember now, which consists of the state of Alaska, the two Western Canadian territories, BC, Alberta, and there's an Arctic caucus. And the discussion at the Arctic caucus was exactly about this, about what are the opportunities for economic development in the context of a changing environment in the north. And I would completely agree with what Stephanie just said. There are very divergent opinions about this. In Canada, in Nunavut territory, there's strong opposition to offshore oil and gas development. The communities on Baffin Island have come together collectively to challenge even the seismic exploration work that's been proposed to do off the coast of Baffin. In the Western Canadian Arctic, you find communities are very pro-development with respect to things like mining. So it's a very complicated situation, and I think for northern people, who I don't wish to speak for the northern people, although I was one myself for a long time, the pros and cons depend on what will be the economic benefits for them directly. And I think for many communities, the economic benefits have been in the past very limited. But again, there's great regional variation there, so I think it's very complicated.
Well, and the only thing that I would add, is who is doing the talking in regard to the pro-development as opposed to the concerns in regard to climate change. And I just have to say, being here, it's like this is affecting all of us, and we don't understand really the implications of what we've set into motion in regard to the changing of our environment. I live in Anchorage, Alaska. We have just had the hottest, most humid summer. Like the humidity, we have never had that humidity in Anchorage. And we don't know what that means in regard to how else our environment is going to be changing. And so while it looks like there are going to be these economic opportunities, who knows? Because we have just fundamentally changed our working knowledge of our environment. And what is going to be possible, I think, is an open question.
Brad?
So Scott, I wanted to ask you a question because I'm not sure I heard you correctly when you were talking about the interests that are looking at shipping through the Arctic, understanding the high degree of variability and planning for it. I'm not sure I heard you say that, but I thought I did. And if that's the case, how do you plan for shipping routes and the associated infrastructure in a situation of high uncertainty? What are they thinking about in order to deal with that?
Yeah, that's the million-dollar question for operators in that space. I think at the moment there are really only a few shipping companies that are looking seriously at the Arctic, and they are shipping companies that have been working in the Arctic already for some time, involved in destinational shipping, shipping of niche bulk cargoes. So far, no large or no container ships of any kind. There are still enormous uncertainties, economic uncertainties, over the viability of any Arctic route for transit shipping, for leveraging the distance savings of the Arctic towards a business case. And so even the operators that have been, even the shipping companies that have been operating in the Arctic for some time they're keeping an eye on it, and they're more aware of the operational uncertainties in the Arctic than anyone else, short of the scientific community. But they're not really looking at the Arctic very seriously for economic purposes until there's like a demonstrably robust season for, I would say, at least a month or more. And that would have to be something that you could plan for at least 6 months out for many shipping purposes. So something to look at for the next several decades, absolutely. But the near term is still very much a big question mark.
So just a quick follow-up. So the push to build some ports to support shipping is not necessarily coming from the shipping community?
Well, it's supported by the shipping community in the sense that those infrastructures are kind of a prerequisite and provide assurances provide reassurance to the industry community that if there is a hazard, that they will be looked after, that there will be search and rescue and things like that. But it's sort of a necessary but not sufficient condition, I guess is the way I'd put it.
So we had some discussions with insurance companies, and Brendan raised this issue earlier, so I wanted to come back to it in this context. And it was amazing, actually, what they don't want to have to pay out money, right? So they have this incredible checklist. Remember Osa, who was at the meeting that we were at, she said, you know, do you have an ice pilot? You know, how good are your maps? Show them to us. What is the distance to search and rescue? You know, they had this incredibly detailed checklist, and it would be the kind of thing that we would want to impose. And they're kind of self-doing this because they don't want to be liable. They say it's not a question of if there'll be some kind of accident, it's just a question of when. And they don't want to be the one that's actually insuring the ship at that time. Dave had wanted to come in, and then Radley.
Yeah, just kind of a follow-up on the shipping. I agree with all of that. When I talk to shippers, it's all, especially containers, it's all about reliability. And they tell me 6 to 8 weeks minimum, basically guaranteed, you know, where you could do an open water transit, and we're not close to that. So I would certainly agree. The one wild card is kind of these big cruise ships that are starting to go up there. That's a lot of people. And, you know, in the words of Admiral Thad Allen, he said he'd fly a C-130 over and count the bodies if they have a problem. So that was kind of sobering. Just my question on your presentation was, you showed some of the models kind of favoring the Northwest Passage, a lot favored the open Arctic. Did your models account for, like, the technical characteristics of that navigation detail, such as draft, how hard it is, all that sort of thing? Because what I understand is the Northwest Passage is probably never going to be a really major commercial route, because a lot of it's less than 10 meters deep at the shallowest point, and that's going to preclude a lot of current generation ocean-going vessels.
Thank you for the question. Yeah, actually, to simplify matters from an intermodal comparison point of view, I actually limited my analysis to the McClure Strait, Lancaster Sound passage through the Arctic, through the Canadian archipelago, to which, for one thing, it takes care of the bathymetric constraint, but it also prevents you from having to account for a lot of resolution issues. In a lot of models don't resolve the Canadian archipelago at all, much less the more narrower straits. And so all of the results I showed were if there was a passage through that the widest and least depth challenged route through the Canadian archipelago, then we included it in the analysis. Otherwise, we just decided it wasn't. That there were too many issues from an intermodal comparison point of view to include that in the analysis.
Bradley?
Hi, I'm curious to what extent shipping industry is considering possible changes in storminess or wave height, or if that's at this point sort of a second order, viewed as a second order issue that you'd sort of worry about later, because, you know,
My understanding is they're very interested in it, and there are some newer studies that I think have just recently, in the last couple of years, that have come out that have kind of taken the access modeling approach that I showed here and added the additional constraint of wind fetch. And so from an operational perspective, it absolutely matters. It's not something that I showed here today, but it absolutely belongs in the conversation.
I'm sorry, I forgot your name. and then Peter. And then with that, I think we should break for lunch afterwards.
It's Brendan's older sister, Kathleen.
Oh, right, that's right.
Since we're on the topic of shipping, I wanted to ask if your models considered fuel use, projections of fuel use in the Arctic. The Arctic Council identified heavy fuel oil spill as one of the biggest shipping risks in the region. And do you expect substantial use of heavy fuel oil in the Arctic or more distillate? What do your models show?
Great, thanks. So these results didn't take into account fuel use, but it's already being used. I mean, heavy fuel oil was famously not banned in the most recent discussions of the IMO Polar Code, and so it's still there. I mean, the conversation about whether it should be banned is ongoing and will continue, but it remains a concern, a really significant environmental concern. There are some vested interests in the shipping space in the Arctic that don't want heavy fuel oil to go away, and that will, I think, continue to remain a sticking point between those interests and those concerned about environmental protection.
Peter?
Just quickly on the shipping and the thoughts that the industry has. I recently had a chance to talk to some people from that industry, and I was surprised about how wide-ranging they are thinking, not just about the environment, the uncertainty, the risk, because as business people they typically are used to some of that, but also about what kind of infrastructure, what transit, what kind of cargo can you actually do with all the real-time production and a seasonal shipping route, how you sort of fold that kind of traffic into a global ship traffic in terms of ports of entry and things like that. So they are thinking that through at a level that we often don't really anticipate, where we think, oh well, they're just sort of, they're not cognizant of that. But I have to say they're driving that fairly rapidly forward, at least in terms of outlining what it would be, what the timelines would be, and in my view, at a fairly high level of sophistication of understanding all the issues that were brought up in the discussion.
Okay, well, with this, let's thank our speakers for this morning's sessions, and I think they set a really strong foundation for what we'll be talking about the rest of the time, and you can see also through this the range of expertise. One thing, sort of programming note I just want to say is it did sound very marine, right? We have, yeah. So we're aware of this, as we put this together on short notice, but we do have more terrestrial people who are here, and they'll just be speaking in later sessions, okay? So you can look forward to those, yep.